定刻となりましたので、第113回国際 ARC セミナーを開催させていただきます。司会をさせていただきます。苦戦隊長の鈴木です。どうぞよろしくお願いいたします。それでは、お二方目のご発表に移らせていただきます。お二方目は、本学情報理工学研究科の、博士課程後期課程在学中の張宇涛さんのご発表です。日本語のタイトルは、くずし字翻刻のための古文用音声認識システムの検討。英語のタイトルは、A Study on Speech Recognition System for くずし字 Transcription。張さんは、he's going to give us a talk in English today.
Yeah.
Yes, so if you are ready, please.
Okay. 声聞こえますでしょうか？
大丈夫、OK です。
今日は英語で発表させていただきます。はい。Good evening, everyone, and welcome to today's International ARC Seminar. And first of all, let me thank you all for coming here today. And Ogida Sensei has just given a really great presentation, and I also learned a lot from her. And my name is ZHANG, and I come from Ritsumeikan University, the Cosmic Signal Processing Labs, and I'm a doctoral student. Today, I'd like to talk about our research about speech recognition system for Kuzushiji transcription. Since we have 30 minutes in this section, so I'd like to give you the outline firstly, to help you focus on. Okay. This presentation is structured as follows. Firstly, in the background section, I'd like to introduce the Kuzushiji transcription and why we want to introduce the speech recognition system into the Kuzushiji transcription. And next, I'd like to introduce the speech recognition technology. It will contain some simple mathematical knowledge, but I will try to let everyone understand it. Then in the section of construction of speech recognition system for Asian text, I like to talk about how we use action text to construct the speech recognition system for Kuzushiji transcription. And next, I will introduce the evaluation experiment that checked the performance of the system we built at the moment. And finally, I'd like to talk about the future work of this research. Okay, about the Kuzushiji, it means the characters used in the pre-modern materials such as the ancient book and the historical documents. And as we know that in Japan, there are millions of these historical books and documents. And in recent years, many institutions has begun to publish them on the internet, so people are able to access the information much easier. But the problem is that many people today cannot read them. Based on the private studies, there are very few fluent readers for Kuzushiji today. So in order to make better use of these historical materials, people want to convert Kuzushiji to the contemporary characters, the normal Japanese characters. So we use today, and it is the Kuzushiji transcription. And as we know, nowadays, the importance of digital data is increasing. Comparing to the analog data, such as handwriting data, the text data is much easier to store, to query, and to use in many fields, such as the text mining, which is really popular in recently. And it is the same in the field of Kuzushiji transcription. We demand for transcription as text data, but it requires a lot of work, and due to the lack of human resource, as we mentioned before, there are few people can transcribe the Kuzushiji. Some AI nowadays, some AI and OCR of the optical character recognition technology has been attracted the attention in recent years. They utilize the technologies such as the image processing, image recognition. For example, in the image we showed here, the Kuzushiji characters can be recognized and transcribed to the contemporary characters automatically based on the AI. But the current situation is that among the people who are good at the transcribing Kuzushiji, there are many humanities researchers, and the elderly people. They are not accustomed to input data according to rules and operate computers. They can transcribe more efficiently using the familiar and analog method than using Kuzushiji transcription technologies that utilize the AI or OCR technology, which requires relatively complex operations. Meanwhile, there is also a demand for text data of transcriptions that experts have handwritten in their own hand in the past. So we want to develop a system that can assess people who are good at transcribing Kuzushiji without placing the additional burden on them, meanwhile achieving an efficient conversion of transcription into text data. And in order to reduce the load, and improve the efficiency of transcription as text data, we are considering introducing a speech recognition system for Kuzushiji transcription. Before from source material, experts transcribe Kuzushiji and create a manuscript with contemporary characters, and then convert the manuscript into text data. But after introducing the speech recognition system, experts can read out the source materials or the manuscript that they have transcribed before, and the speech recognition system will recognize the speech and output the contemporary characters. And finally, the expert can correct the recognition result, and that's finished. I think you can see that the most important things of this system is the performance of the speech recognition system. So, and I'd like to talk about it now. Okay, firstly, I'd like to briefly introduce the speech recognition technology. The speech recognition, it could also be called as the speech to text. As the name implies, it is the recognition and translation of spoken language into text by computers. It has been used in many occasions, such as disability assistance, especially for the visual impaired people. It can help them to translate their speech to the text, for such as inputting. And it can also be used in the education, for example, in the English learning, foreign language learning. And I think the most common application is in your mobile phone. For example, Siri in the iPhone, they utilize the speech recognition technology to translate your voice to text data and utilize other technologies such as the natural language processing to understand the meaning of your words. So when you say, "Hi Siri, show me the weather today," and it can show you the weather forecast. And the research on speech recognition has going on since the 1950s. But I think the breakthrough come after deep learning was proposed. Here I list the popular technology for speech recognition recently. We can see that before the deep learning era, the Gaussian vector model and the hidden Markov model was really popular. And after the deep learning era, the popular technology became to deep neural network and hidden Markov model and end-to-end technologies. I showed here a result of review paper about the performance of technologies before and after the deep learning proposed. We can see the horizontal axis is the technology before and after the deep learning proposed, and we can see the horizontal axis, and is the amount of training data, is the word error rate, and it's word error rate and and we can see about the word error rate. Smaller word error rate, the better performance. And so we can see no matter the amount of training data, there is a big gap between the technology before and after the deep learning era. And we can also see that no matter what technology is, to achieve a good performance, the amount of the training data is really important. Considering the amount of data in our hands, we decide to use the DNN and HMM model at this stage. Here, I'd like to give a detailed introduction about how speech recognition system work. I have listed some function here for the people who have an interest in mathematics and have a certain mathematical basis. But if you cannot understand it, do not worry. I will explain it without understanding the functions. The basic framework of speech recognition is the problem of finding the most likely word string for the input speech signal. So we need to calculate the probability of altered each word string when observing a speech signal and find the biggest probability sentence. And based on the mathematical manipulation, in order to calculate the probability of altered text sentence when observing a speech signal, we can calculate the probability of speech signal when given a word string, which a acoustic model can give us, and the probability of word string being heard in a specific natural language, which language model can give us. For example, in Japanese, Ohayu is much easier to be heard in Japanese than Obayu. So the language model will give higher probability of Ohayu than the Obayu. And here is the structure of speech recognition system. Firstly, when the audio input, we will conduct the processing, the pre-processing. It includes such as acoustic feature extraction, the voice activity detection. and the voice activity detection, which can find the section in a period of sound that high voice, and because we just want to recognize the part with voice. And based on the acoustic model, which assigns the conditional probability that a speech signal is likely given a word string, and the language model, which assigns the trained probability that a word string is likely, and also the pronunciation dictionary, which specify the vocabulary to be recognized and its pronunciation. The recognition engine will search for the maximum likelihood word string and output it. It is the recognition result. And the acoustic model and language model are trained with a speech database and the language database. And normally the speech database and the language database need a large amount of data. But as I mentioned, as I mentioned before, language model will assign the giant probability that a word string is likely for a specified natural language. But when for the speech recognition system for Kuzushiji transcription, if you use the general contemporary Japanese language model, for example, the language model trained by the Gendai Nihongo Kakikodoba Kingo Compass, the result is not good. It can't get the exact recognition accuracy. So to achieve a good performance of the speech recognition system for Kuzushiji transcription, we need construct a new language model and a pronunciation dictionary for speech recognition system for Asian text. And here is the detail of introduction of statistical language model. And I'm actually going to skip over this for the reason of time, and it's hard to understand. And I just want to mention that we use the n-gram model for the language model. And this model calculates the probability of observing the ith words vi in a word string depend only on the previous word. And the advantage of this kind of model, I think they have two advantages. The first one is easy to train, and the performance is really good. And here is about the procedure of construction of language model for speech recognition system for Asian text. And for the construction, firstly, we will prepare the training data. We will prepare a large amount of Asian text data. And then we will processing the training data. It includes such as split the data into the sentence or morphological analysis, or remove the unnecessary parts. And then we will build a dictionary. In the dictionary, we will list the vocabulary, and then we will add the pronunciation to each word. And then we will estimate the n-gram from processed training data. And to improve the performance of the system, we also calculate the back of n-gram model. It's opposite of the n-gram model. The n-gram model, it is estimated from the end of the sentence to the beginning. And about the current target for speech recognition, we only focus on the Asian text from the Edo period. And the language model about the language model and the pronunciation dictionary built at the moment, we use the training data of Edo Parrot Xiaolobong, and it has 15 workers, and we conduct the morphological analysis by electric dictionary and the Nihongo Lekishi Compass. And here I list the works of in the training data. And I want to mention that the number of the characters in the training data is about 170,000. And the number of words in the pronunciation dictionary is almost about 12,500. And after that, we also conduct experiment, an evaluation experiment to check the performance of the language model we built at the moment. And about the experiment procedure, we use the test data. We use the test data that is reading data of Xiaolobong, and the content is a part of Hijiri no Yugaku, and the length of it is about 4 minutes. And we use the speech recognition software Julius. It's developed by the Kyoto University. It's an open source software, so we use it. And the test data in the experiment, the test data is recognized with following 3 language models. The first model is the general contemporary Japanese language model. It's trained by, we also called the general model, and it is trained by language model. It's trained by the Gendai Nihongo Kakikodoba Kingo corpus. And then we conduct a closed test. In the closed test, the language model is trained with the training data containing the test data. We conduct the closed test to confirm whether the model has been trained successfully. And then we also conduct an open test. It means the language model is trained with training data without test data. And I think, yeah, it's much closer to the practical application. And we conduct it to confirm the recognition performance for Asian text, which is not included in training data. And here is the evaluation index that we use in the evaluation experiment. It's the character error rate, and it calculates like this. We will plus the number of the substitutions, number of deletions, and number of insertions. That's the arrow, and divided the number of characters in reference text. And I also show the experimental result here. Here is you can see that the horizontal axis is also the CER, and we can see that this horizontal axis, the horizontal axis is show the 3 saturation of experiment, and the vertical axis is the word error rate. And about the word error rate, the smaller word error rate, the better performance. So we can see for the general contemporary Japanese language model, it can get a result of 59.8 CER. It's ready per. And for the closed test, it can get a result of 17.4. It's good. It's a good result. And for the open test result, we can get the 50.3 CER, and it's not so good, but it's better than the general contemporary Japanese language model. And I also show the detail of the experiment result. And here I showed the total number of the characters and total number of erroneous characters and the character error rate and the character recognition rate, which calculate by the character error rate for each situation that we conduct in the experiment. The general model, the closed test, and the open test. And here is the example of the recognition result. You can see I have showed two results. I choose two results. The first one is the good one, and for the second one is the poor one. Firstly, let's listen the taste sound of the good result.
心を和らぐるもゆかりの月の一節とかし。
Yeah, you can see the results. The closed taste and the closed taste and the open taste is really good about the recognition result. But the general model about the result of the general model is not so good. And about the per recognition result, let's listen the test data first.
マスティン様、この中横おぼりでお見受け申しましたゆえ。
Yes, here is the per. You can see that the general model, the closed test and open test, they all get a bad result of the bad result. Yeah, but the closed test and the open test seems like better than the general model.
心を和らぐるもゆかり。
I'm sorry. And about the evaluation experiment, firstly, the language model, we found the language model has been trained successfully because in the closed data, the CER is low. It means the result is good. It's about 17%. And the language model and the pronunciation dictionary constructed at this time were able to improve the recognition performance of the Asian text that we found it. According to the result of the open test, the language model constructed at this time has improved the recognition performance compared to the general language model. It's almost 10% CER. And we believe the result improved the feasibility of introducing a speech recognition system for Kuzushiji transcription. But yes, as we see, the result is not good enough. So we need to further improve the recognition performance. And about the future work, we want to improve the recognition performance. And we are thinking about two methods. Firstly, we want to increase the data for training the language model. And secondly, we want to improve the accuracy of morphological analysis. And then when we have enough data, we will end-to-end speech recognition will be contracted to further improve the recognition performance. In the end-to-end speech recognition, I have shown the structure below. It can predict the words and the sentence directly just from the acoustic feature. And it's really state of art. It means the result is really good now. But because in this method, we need to train a really big, really huge neural network. So it means we need a large amount of training data. and for now we do for now we can't, but when we have enough data, we will try to conduct this kind of model. Oh, that's all for my presentation. Thank you all for listening. 私の発表は以上になりました。
Thank you, Chang-san, for the presentation. It's really state of art, amazing. From the audience, if you have questions or comments on Chang-san's presentation, please speak up or raise your hand, please. Any questions? So I have a question. So you use the Sharabon called いじり遊郭?
So this. Yes, I use it.
So, and you also mentioned towards the end, if you feed more ancient texts, your accuracy rate will improve.
Yes.
And so the reason why did you use Sharabon among many books available? It's kind of like my understanding of Sharabon is kind of like a full of linguistic puns and jokes.
Sorry, what the
Sharabon. What's the reason you choose Sharabon among many ancient books?
It's just the first. In fact, we want to use this system for all the ancient book for the Kuzushiji transcription. It's just the first day we want to confirm the feasibility of this study. Is it's okay or not? Is possible or not possible? So we choose. This is the first stage. We choose because we only focus now in the first stage we only focus on Asian texts from the Edo period. So we just choose the Sharabon.
Yeah, but the reason I'm asking question is Sharabon is kind of like a very popular and commoners kind of language.
Yeah.
I think the target is not the elite, but more townspeople's as a readership.
Oh.
So I was wondering why you chose the book.
Yes. In the future, yes, we will use another. Yes, we will try to use another books or the documents to train the model.
Right. Yeah. So you right now you showed us the table or the books you used for this machine, and I think quite a list.
Oh.
All right. Thank you so much.
Oh.
All right. So it's like I could see some literature, very popular kind of.
Yeah, it's very popular.
I see. Thank you. Wow. All right. Thanks. Any other question?
いいですか？
よろしくお願いします。
張さんいつもありがとうございます。
ありがとうございます。
質問というか今のに補足なんですけど、私もこの、プロジェクトにちょっと参加させていただいてるんですけど、シャレ本のテキストを使用したのは、それがすごく使いやすい、すぐ手に入るテキストだったっていうのと、あと今後の展開として役者評判機のテキストデータを使用することを考えていて、特にそのシャレ本が書かれた時代のものを使うことを想定してたので、それで揃えるような形でテキストを選択したっていう背景もあります。ということを一応補足します。
ありがとうございます。
ありがとうございました。
In English, it seems like because the data is popular, it's easy to get for the training. And
Yeah,
for the
well,
first day, yeah, we use this kind of data.
So Totsuka-san's input really helped us understand the choice of the book. So
Thank you very
you
much.
and Totsuka-san have a long-term project
Yes.
plan, and so for it kind of like for the first step,
Yes.
you chose a book. So the books coming after that will be in the kind of like the same time period focus.
Yes.
With the kind of like the same kind of readership.
Yes.
All right.
Thank you very much.
That makes sense. Thank you. ありがとうございました。
ありがとうございます。
ありがとうございます。
他いかがでしょうか。よろしいですか。
日本語の問題も大丈夫です。頑張って答えします。
いや、よくお分かりになっていると思いました。はい。他いかがでしょうか。英語でも日本語でも結構です。よろしいですか。内容でしたら、ちょっと早いですが、これで終了したいと思いますが。
じゃあちょっと早いようだったら、ちょっとだけ赤間ですけど。
はい、お願いします。
補足ですね。私もこのプロジェクトに参加、くずしですから参加してるのは分かったと思いますけど、くずしを読むっていうよりは、面白いのは古典語を音声で、古典の言葉を音声で読み上げたものを、テキストにするっていう、おそらくは全く、誰もが思いつかない、プロジェクトなんですね。で、なんだけども、それを、このくずし字を翻刻するっていうシステムに、くずし字というか、古典語を読み上げる、それから、くずしを翻刻するっていう、今、大田先生も、発表したような課題があって、それと結びつけると、一つの、今までというか現在よく、こう進んできている、AI によるくずし字の画面から読むくずし字の翻刻の方向と全く違うアプローチによる、古典というか歴史的な文献のテキスト化につながるっていう、そういう発想になると思うんですね。で、なかなかちょっとそのつながりが、理解できないのかなとは思うんですけれども、今、AI を使った画面から読むというんではなくて、音から読むっていうところ、音からテキストを作るっていうのかな。そこの特徴がある、システム開発をされているっていうところがポイントかなと思っています。ちょっと補足です。うまく説明、スムーズに説明できないので申し訳なかったんですが、そんな、一応方向性はそんなことだと思うんですね。はい。
説明ありがとうございます。
天先生、ありがとうございました。 他よろしいでしょうか。はい。それでは、ちょっと早いですが、チャンさんの発表はここまでとさせていただきます。どうもありがとうございました。
ありがとうございました。
はい。それでは、本日の発表はここまでですが、これが今年最後の、国際 ARC セミナーとなります。皆様ご協力ありがとうございました。来年1月ですが、次回は1月18日に、次回の国際 ARC セミナーを開催いたします。ちょうど今日ですね、質問をしてくださいました、あたかさんと戸塚さんの、ご発表を予定しております。あたかさんの方からいただいております、発表のタイトルは、近世後期における奈良の寺社の実相、奈良奉行、川地俊明の日記、ネイフ記事から見えてくるもの。戸塚さんの方の、ご発表は、戸塚しおりさんのご発表タイトルはいただいておりますのは、勝川派の浮世絵作品に見られる改め印の問題と、いただきました。1月18日、この時間です。また、ご参加くださるようにお願いいたします。それでは、他先生方から何か、ご連絡とありますか？はい。それでは、これで閉会させていただきます。皆様、今年もいろいろありがとうございました。どうぞ良いお年をお迎えくださいませ。これで閉会いたします。